Have you ever asked yourself why we are still traveling at 1,960 speeds? Modern airplanes have become much quieter, more economical, and more comfortable, yet their speeds have remained virtually unchanged over the past half-century. The team at Boom Technologies dared to change that with one of the world's most ambitious supersonic aircraft designs, the Boom XB-1. And today, we'll tell you about this futuristic device, its perspective outlook, and find out how its first supersonic flight over the Mojave went. In just 44 years over the first half of the 20th century, humanity evolved from the first manned flight of the flyer by the Wright brothers in 1903 to breaking the sound barrier at speeds above Mach 1 by Chuck Yeager piloting the experimental Bell X-1 in 1947. But even this was frankly not enough for us. Another 30 years later, in 1976, the British-French Concorde became the first successful supersonic passenger commercial aircraft, exceeding Mach 2 with a cruising speed of 1,341 miles per hour. However, by 2003, commercial supersonic flights completely ceased, and since then, the time required to fly from Paris to Rio de Janeiro or from New York to London is no different than what was offered to humanity half a century ago. Overall, first-generation commercial supersonic flight, supported by governments and with limited regard for economic viability, fell victim to their own enormous fuel costs as well as disproportionate noise and emissions levels. The takeoff noise of the Concorde was 115.4 effective perceived noise in decibels, EPNDB, which is even louder than listening to a rock concert right next to the stage and speakers or listening to a chainsaw or jackhammer less than a couple of feet away from you. In terms of fuel cost, the Concorde consumed 1.2 gallons of fuel per 17 passenger miles or 4.38 gallons per 100 passenger miles. And for every passenger flying 1 kilometer in Concorde, 42 kilograms of CO2 was generated, despite the fact that even the not-so-green Boeing 787 or Airbus A350 generate only 1 to 1.5 kilograms of CO2 per kilometer. At the same time, the fuel efficiency and noise performance of modern aircraft have improved greatly for subsonic flight in recent decades. Subsonic aircraft now produce 80% less CO2 per seat than the early jets from the 1960s. Generally speaking, given the current rate of development of the same engine architectures with a high bypass ratio as well as the principles of natural and hybrid laminar flow control, fuel efficiency is guaranteed to increase by another 30% in the next 10 years. Likewise, aircraft noise has decreased by more than 90% since the first jet aircraft entered service. The only thing that's remained constant was the speed. But for how long? In October of 2020, Boom Technology, which began as a small startup out of Denver, Colorado, took the first step toward reintroducing commercial supersonic flight with the unveiling of its prototype of the first private supersonic aircraft, the XB-1 or Baby Boom. Measuring 62.6 feet long with a 21-foot wingspan, this prototype seamlessly combines low-speed takeoff and landing stability with high-speed efficiency. Yes, it's a far cry from the impressive 202-foot Concorde with its 84-foot wingspan, but let's not forget we're still talking about the first prototype, and the name Baby Boom unironically hints at the size of the craft. The main visual difference from its grandfather Concorde, which immediately catches the eye, is the absence of a downward inclined nose. Granted, in contrast to the characteristic long nose present in both the Concorde and the Baby Boom, dictated by the improved aerodynamics of a supersonic vehicle, the tilt of the latter was due to the simple need for pilots to clearly see the runway. But the XB-1 achieves this well with advanced cameras, high-resolution displays, and a variety of sensors installed on board. Lightweight composites, stainless steel, and titanium were chosen as the main body components for the XB-1. Moreover, the rear part of the aircraft around the engines was made with 90% titanium and only 10% A286 stainless steel alloys. In terms of supply materials, Boom Technology got lucky. They had the Dutch company 10K Advanced Composite in mind, which has been proven by SpaceX itself in their Falcon 9. They provided the team with the necessary materials for the hot leading edges and nose, designed to withstand temperatures greater than 370 degrees Fahrenheit, as well as epoxy material for the cooler parts. For the glider, they used intermediate modulus carbon fiber epoxy with high modulus fibers for the wing spar caps and Bisma-made prep rag for the high-temperature leading edges and ribs. Baby Boom propulsion system consists of 3 General Electric J85-15 turbojet engines, collectively providing more than 12,000 pounds of thrust. These are the same ones we're used to seeing in the Northrop F-5 Freedom Fighter and Northrop T-38 Talon jets. Choosing the J-85-15 will give the XB-1 a speed of Mach 2.2 and a range of more than 1,200 miles. In the near future, they'll be replaced by Boom Technology's own engine, Symphony, developed in conjunction with world-class suppliers including Kratos Defense and Security Solutions, Florida Turbine Technologies, GE Additive, and Standard Aero. The thrust of this monster is 35,000 pounds, providing 25% more time on wing, 10% lower operating costs, and, most importantly, optimize the work on 100% sustainable aviation fuel. According to the manufacturer, the aircraft is one of the highest efficiency civil supersonic engine intakes ever tested. To use the power of the engines even more efficiently, additional information about variable geometry has repeatedly shown up with things like intakes as well as exhausts, which will greatly affect the reduction in the noise level created by the device, for which Baby Boom was originally designed. We're talking about the main project over at Boom Technology, the supersonic futuristic airliner Overture, designed for 80 passengers. This giant can easily compete in size with the legendary Concorde. Its length is 201 feet, and its wingspan is 106 feet. The engine Symphony, which we mentioned earlier, is also made specifically for Overture. However, unlike the prototype, the airliner will have 4 engines, not 3, with a total thrust of 140,000 pounds. Although the team decided to move away from the original Mach 2 concept in terms of speed, reducing the Overture requirements to a cruising speed of Mach 1.7 with an operational range of approximately 4,900 miles, this is still twice that of any modern passenger aircraft. Moreover, where else but on board the Overture at an altitude of 60,000 foot will you be able to see the curvature of the Earth in the next 5 to 10 years? But let's go back to the prototype. It took the Boom team several years of hard work to prepare the XB-1 for its first flight, and so in March of 2024, official tests kicked off toward the main goal, overcoming the Mach 1 benchmark. On January 28th, after about 10 months, 11 test flights, and more than 7.5 hours of Baby Boom pilots in the airspace, the XB-1 entered the supersonic corridor under control of Boom's chief test pilot, Tristan Brandenburg, reaching an altitude of 35,219 feet, accelerating to a speed of Mach 1.22, and breaking the sound barrier for the first time. Of course, such a high-profile event couldn't just happen without any symbolism. This event occurred in the same legendary Bell X-1 supersonic corridor in which Charles Chuck Yeager once performed the same trick for the first time. Even today, this spot in the Mojave remembers well the many historical first flights that took place there, such as the North American X-15 or the Lockheed State Route 71 Blackbird, which have since repeatedly spread their wings around the area. And now, the XB-1 awaits further testing at the end of 2025. In the meantime, the Boom team will still work toward its fundamental goal of releasing the first Overture in 2026, preparing for a test flight in 2027, and successfully passing all necessary Federal Aviation Administration certification procedures by 2029. So we figured out the timing, but many probably want to hear that the future is now. According to Boom, one Overture commercial airliner will cost approximately $200 million per unit, which, no less, puts it in the same price category as a future American sixth-generation fighter aircraft being developed as part of the next-generation air dominance program. Moreover, assuming interest from the military, Boom Technology CEO Blake Scholl clarified that the military configuration will cost more. It's not for nothing that Northrop Grumman was among the first to become interested in a supersonic device, subsequently making an official announcement regarding cooperation on the Overture project with the goal of delivering medical supplies, providing emergency medical evacuation, or monitoring large areas faster than conventional aircraft. On the other hand, Boom has been collaborating with the U.S. Air Force since 2020 to create a separate Overture modification for high-speed delivery of cargo and personnel. As such, all the threads are coming together at the Defense Advisory Group, which aims to help identify unspecified national security missions the aircraft could be used for. Meanwhile, among the investors in the future of passenger air travel, we've got American Airlines, United Airlines, and Japan Airlines, which have placed a total of 130 pre-orders for Overture airliners. Hearing this, many might be puzzled by a fair question. How does a startup from Denver, albeit an extremely successful one, intend to scale up to such an active production of its aircraft in the future? The answer is the Overture Superfactory, which recently opened in Greensboro, North Carolina. It's through their efforts that the company will be able to produce up to 66 airliners per year starting in mid-2027. In the meantime, all we can do is sit back in our own chairs in anticipation of when ticket sales begin on board the future of aviation, which, to some degree, has already arrived. If you've heard about other projects that create supersonic aircraft, don't hesitate to share what you know in the comments. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.